What is the area under this line where x value is 0 to 2 using calculus for this function of y equals 2x? Some of you are saying calculus. I don't know calculus. Some of you others are saying that we can use geometry and no need for calculus to solve this problem. Hi, my name is Patrick and welcome to my YouTube channel, Better Math. First, let us solve this problem using geometry, and then I'll explain on how we can solve this problem using calculus. As the range is 0 through 2, and we want to find the area underneath the line of y equals 2x to the x-axis, so I highlighted this with the gradient blue for the area that we want to find. Please pause the video and try to solve this problem if you think you can do it. And let us first try to solve this problem using geometry. Some of you are not sure on how to solve this problem with geometry, so let us continue. First, we need to find the coordinates from 0 to 2 to get a triangle. We will begin with the value of x equals 0, starting part of the area that we want to find. Now we substitute 0 for the value of x into the equation of y equals 2x, and we will have y equals 2 times 0. When we do 2 times 0, this will be equal to 0 for the value of y. We will want to get the endpoint of the line. Now we will find what y is when we have x equal to 2. First, we'll substitute x with the value of 2 to get y equals 2 times 2. And then we will do 2 times 2 equals 4. And we will find that y equals 4. So we have found the points on the line that we are wanting to find the area. We have found the first point of 0, 0, which is 0 for the x-coordinate, followed by 0 for the y-coordinate. The next point is 2, 4, which is again 2 is for the x-coordinate, followed by 4 for the y-coordinate. Many of you may see that the area is a triangle that is formed by y equals 2x, where the area underneath the line which forms a triangle. If you remember that the area of a triangle is half BH, or half of base times the height, and this can help us solve this problem using geometry. Some of you may have noticed that this triangle is a right triangle when we draw the vertical and horizontal lines forming a right triangle. And since this is a right triangle, we have b, or the base, to be equal to 2, which we have found. Next, we have h, or the height, to be equal to 4. Now we will substitute the values into the area of the triangle formula, where we'll have 1/2 times 2 times 4. 1/2 times 2 will cancel each other out to the value of 1, and this will leave us the answer where the area underneath the line to be 4 square units. Some of you are asking, why are we using square units? We're saying this because there are no measurements like inches or centimeters or so forth were given, so we use the default to say square units when we're finding the area. We have just used the area of a triangle formula of 1/2 b times h, or 1/2 base times the height. Some of you are aware that the area of a circle formula for pi times r squared, or pi times radius squared. Another formula to find the area of a rectangle, which is L times W, or length times the width. And the area of a square is S squared, or the side squared. These are just some of the formulas that we can use to get the area or volume of these shapes. But not all shapes out there have formulas to get us the area or volume. For these shapes, this is where we can use calculus to find these areas and volumes. You can try to come up with general formulas for these shapes, but there will be a new need for a new formula for each new function that is slightly altered. How about this, where we have y equals 2x plus 1 for this line? Yes, you can use geometry to solve this problem as well. Of course, after we have figured out the coordinates for the rectangle, and we will then find the area of the triangle, which would be 4 square units, and add it to the area, the rectangle beneath the triangle. The area of the rectangle is 2 square units, giving us the total area underneath the line to be 6 square units when we add 4 plus 2 to get the total area. If we were to use calculus, the calculation would be easier to do this problem in less steps. Of course, some of you are saying that calculus is advanced math. Yes, it is advanced math that builds upon algebra, geometry, and so forth. And calculus is a powerful tool in math. Here we have a parabola, which is x squared. There's no geometry formula to get the area underneath this curve of this parabola. Yes, you can use our friend calculus to get the area underneath this curve. Some of you are saying, big I, big phi, you're crazy. Calculus is not my friend. While looking at the cubic function of x cubed, and there is no formula in geometry to find this area. Again, we can use calculus to get the area underneath the curve or above the curve if we're looking take values on the left side of the Cartesian coordinates where the y value is less than 0. Some of you are saying that only engineers, scientists, and mathematicians are using calculus. True, we don't need to use calculus to help us buy groceries or balance our checkbook. Those of you thinking that you want to become a scientist, engineer, or so forth, calculus will be important to learn for these fields. Also, there's business calculus used in business. To get the area underneath the line for the range of 0 to 2 using calculus for the line of y equals 2x, now let us get us an understanding for the calculus notation. Here we have the elongated s to represent that we want to do integral calculus. The dx represents that we are trying to integrate with respect to x. So we could be integrating for y value, or there will be a dy, and so forth. We have set up this calculus equation from the lower limit of 0 and the upper limit of 2. We're taking the range of 0 through 2. We're integrating 2x with respect to x, and that is why we have dx. As we can use calculus to solve this area underneath the line of y equals 2x, here is the setup to the equation to solve this problem using calculus. Calculus mostly covers limits, integral calculus, and differential calculus, where integral calculus and differential calculus are the opposite of each other to their functionality, like addition is the opposite of subtraction and vice versa, and multiplication is the opposite of division and vice versa. One way to think in doing integral calculus is that we take and place 10 rectangles underneath the line of y equals 2x and make these rectangles center and width. We can add up these area of the rectangles. The rectangle has L times W, and the area of the rectangle is length times the width, or L times W. So we keep making the rectangles smaller width and add these rectangles up. They'll give us more accurate value for the area underneath the line. This breaks down to integral calculus. Now we have set up the problem for integral calculus. 0 is for the lower limit in the lower part of the elongated s symbol. 2 is the upper limit in the upper part of the elongated s symbol. And we're taking the integral for x, which is why we put a dx. Of course, we're integrating for the function of 2x. I learned calculus when I was in college. In real life, I'm a software engineer. I hardly use calculus while on the job, though I've used a little bit of calculus. I know that there are other software engineers that used a lot more calculus, such as the GPS software engineers. When I first started in college, I was a math major, but later I switched my major to computer science. Calculus is required for software engineers, so if you think I'm helping you learning from me, or we can make the YouTube algorithm happier, if you like and subscribe to my channel so I can reach out and help other people like you. And thank you if you did that. Enough of this commercial break. Let us continue on to solve this problem. I got our calculus problem set up now. The value of x can be represented as x to the first power, which is the same. When we're doing integration, we'll add 1 to the exponent to the power of the part of the integrating for. Here it is x to the first power, so we can get 1 plus 1 in parentheses. When we add 1 plus 1, that will be 2. And this is the exponent value. We'll be dividing by this value as well, which is 2 in the denominator. Now we will have 2x squared divided by 2. 2 divided by 2 will cancel each other out to become 1. And we will have left over with x squared. Now we will substitute into the upper limit and the lower limit values for x. This will be the upper limit minus lower limit when we substitute in for the value of x. We have done the integral, or sometimes called the antiderivative. We'll have 2x squared minus 0x squared. That suggests we should put the limit numbers in parentheses to avoid problems when we have like negative numbers. So 2x squared can be represented as 2 times 2 on the left side of the equation, and 2 times 2 equals 4. Now we have on the right side of the equation, 0 squared is 0 times 0, and 0 times 0 is equals 0, of course. Finally, we have 4 minus 0. And here we have 4 minus 0. Now, after we do subtraction, we'll get 4. And you'll have the area to be found as 4 squared units. Yay, this matches what we found using geometry. In this case, it's almost the same amount of work doing geometry and doing calculus to solve this problem. Or please remember, calculus can be used for more complex geometry problems or where there's no geometry formula to help us solve these problems. Please like and subscribe. Thank you for watching and have a nice day.